Okay, should be going now to present. Okay, Intro to Web App Security by, well, me. Alright, so overview. First of all, overview of what we're going to cover. What is a web app, or what are we talking about here? I know I personally didn't really know what web app specifically meant, and thought it'd be nice to clear up exactly what we're dealing with here. Second, common faults in web app security. Hint, there's a lot. And I'm going to go through some of the primary ones that came to my mind. Of course, there's a lot of faults. Third, doctrine and mindset of breaking a web app. So, like, what you should look out for, what you should think about when mapping and infiltrating, stuff like that. And finally, mapping a web app and finding an angle of attack. This is the initial step of actually breaking into the web app or finding out how it's vulnerable, etc., etc. Okay, so what is a web app? A web app is something that provides some service or functionality to the end user. It utilizes a client-server model, operates in a web browser, and is pretty much anything you do on the web, or it's therefore pretty much anything you do on the web. So it could be something like, say, bankofamerica.com, or it could be something as simple as the URL shortener. I think it's bit.ly. Client server model. So basically, you're on the client. You're the client, basically using a web browser to access the server. Implicitly, this is through the internet. And as I said, it's pretty much anything you do on the web. So pretty much anything you go to on the internet, any website, is actually a web app. Yes, question?
What is an end user?
End user. So provides some service or functionality to end user. So this was I typed this from the perspective of someone providing the service. So end user is a client, or a customer or consumer, or someone who is using the service functionality or the product that you are creating. So for example, I might be Bank of America, for example, and I'm providing the banking service to end user is a client at the bank who stores money and expects me to keep it safe. Yeah, we'll see how things cannot be safe.
So that's the same thing as a user?
Yes. Honestly, I don't know why I said end user. It was synonymous to me. Anyways, continuing on. Common faults in web app security. So there's a few different ones that I thought of. So first is the crowd mentality, or lemmings, or everyone uses it so it's secure. Second is HTTPS. Third is logic failures, and fourth is client-side security. So I'm bringing these all up first without really explaining them, because I want you to think about how these would seem like they're security features, and they seem like they make things secure, but also how they aren't actually fulfilling their goal of enforcing security. So let's go through them one by one. Crowd mentality, or basically a lot of people using a service. So a lot of people use OpenSSL, but this text is a bit small, but I copied this directly from openssl.org. This was their error report, or not error report. The can't think of what it's called right now, but it's basically them reporting that there's this problem, and this was actually the Heartbleed bug, and it was just last year. It was pretty big news, actually really big news, and there's a lot of different services that use OpenSSL. OpenSSL is basically TLS. The name just hasn't changed because a lot of things are called SSL, but then things have moved on to TLS. It's basically a different method of securing network traffic. And so then this OpenSSL, pretty much stuff like HTTPS, as we'll cover later. Yeah, so this is a very widespread method of securing things, and there's actually a bug with it. And even though a lot of people use it, it's not really secure. And I don't know for sure, but I think because it has open in the name, it's supposed to be open source. So even though this is open source, everyone can see the code, a lot of people are using it, it still has these major faults. And people are able to get social security numbers, able to get certificates, and authentication information from this from Heartbleed. TLS. So question: what is TLS? TLS is transport layer security. SSL is secure socket layer. I don't know the exact difference, but I think SSL is where there's a different. So there's stuff like HTTP and FTP. They're different protocols. So I think SSL was originally made as a completely separate protocol, hence why it uses a different port. I think so, maybe. And then there's TLS, Transport Layer Security, which basically, instead of making a completely different protocol, the network traffic acts exactly the same. Like HTTP packets are still HTTP packets. Oh, I mean, not HTTP, TCP. So the packets are the same, but then internally the data is encrypted, and that's the TLS. That's what TLS is. I'm not too familiar on that, but I think that's what it is. So yeah, next is HTTPS. So it's commonly said stuff like, oh, that green lock in your browser means you're safe. Like HTTPS, a lot of browsers use, well, pretty much the big three would have the green lock. Safari, Chrome, Firefox. This is Chrome here. You can sort of tell from the tab shape. Yeah, I think. Anyways, so there's a common misconception that HTTPS basically means you're secure and nothing's ever going to happen because you're using HTTPS and all is good. But HTTPS just means you're encrypting the traffic. So there's a common saying, cryptography is typically bypassed, not penetrated. And faults in implementation or endpoints are the weak point. So the cryptography itself, or like the encrypted data itself, is not targeted. Usually you don't go brute forcing some AES 256 encryption or something like that. What you do is you go after the endpoints, like the server itself or the client, such as what will be covered in another discussion, cross-site scripting. So the user themselves, or like the server themselves, has some sort of a exploit or some sort of a bug, something like that causes the not the encryption itself, but somewhere at the receiving or the sending point, causes it to be compromised.
Oh wait, so endpoints is...
Endpoint. So I'm not sure if that's actually a terminology used here, but what I meant by endpoint is the start and finish, like the sender and the receiver. Like along the route, it's protected by HTTPS. If you sniff it with like Wireshark or something like that, then all you get is encrypted data, and well, you can't really do anything with encrypted data unless you want to brute force it. And that is the cryptography at that point. So HTTPS secures the data in transit. So if people sniff it, they can't really figure out what it is, what that data contains. So the fault is typically not with the data being sniffed, but with something wrong with the site itself, or the server, or with your own computer. Like there might be someone, like you downloaded malware or something, and it is able to infect your browser itself, something like that. Certificate? Certificate. Certificates are used to are used for SSL and TLS. They're to show that a site is authentic, and I think they also contain data about how the public key, for example, in asymmetric encryption.
I think it's so I think certificate are like for banking sites or something.
Like banking sites. Well, yeah, they are used with banking sites, if they implement that security. Okay, continuing. Another problem is with the implementation logic. So supposedly it's fine. Like with authentication, you might tell the user, oh, you got your username wrong, you got your password wrong. But if you tell your user specifically what went wrong, that's even more information for the attacker to go off of. So they might, if they try both the username and password, or tells them the username is wrong, but then doesn't say anything for the password, then they know that or actually it should be the other way around. The username, it doesn't say the username is wrong. It says specifically, incorrect password. Then that means you know that the user exists, and you just have to guess the password, or something like that. And basically it's giving the user way more information than they need to know. Second is cooldown time between authentication attempts. So if some site or anything really, a program, allows authentication to be made pretty much instantaneously, it doesn't set like a half-second cooldown, which, well, for a human being that would be pretty logical, because the web page would have to reload, they'd have to identify, if something went wrong and retype their password or something. But for brute force, like a toolkit, not a toolkit, I mean, like Hydra, for example, or like some sort of software that specifically brute forces passwords, then what can happen is that because there's, say, just 1 millisecond between trying each different password combination, or user and password combination, then that means that they could get through the program, or get through the authentication very quickly. They could try 100 combinations in 100 milliseconds, versus if you have just a half-second delay, then 100 tries means you have to take 50 seconds. I think so. Just did the math in my head. I think that's right. Anyways, yeah, sort of not really concentrating right. Anyways, so yeah, it's best to have some sort of a cooldown between tries, or else it could really easily be and really quickly be be compromised by brute forcing. And finally, logs, errors, and debugging information will help attackers more than users. So the user might have done something wrong, accessed the wrong page or something, and then the server spits back an error, or some sort of script to make sure the right information is entered. It might throw back at the user a whole bunch of like debugging information, like say syntax error here and here. That helps the developer. It might help the user if they know what they're doing, but in the end, if attackers see that, that is a lot of help for attackers, because as you'll see later, when we talk about the mindset and doctrine for infiltration, you'll see that the goal of attackers is actually to sort of build a picture of what's going on in the back end. So conceal your server backend. Don't let them see what's going on, in the server. AKA hide your ass. Yeah, ha ha ha. Anyways, error checking only on the client side. Anything the server anything the client can handle, the client can compromise, whether it's they're physically handling a computer, or if the authentication is just done in a JavaScript file, which is client side. It's as clear as day as the HTTP or I mean the HTML source code of a site. So if the client can handle it, the client can compromise it. So nothing should purely, or the security should not purely be on the client side, or else it's very easy to circumvent. Second, the idea behind it is that it would give significant speed and load improvement by handling the user info and making sure there's no problems before sending it to the server. And that is correct for regular users, but if there's someone trying to break into the server, malicious intent, then they could very easily bypass that. So although there is performance improvements, there should also be other considerations, which means the error checking needs to also be replicated on the server. So, doctrine and mindset of breaking a web app. So the idea is to form an idea of what's going on in the back end. Everything from the file structure, like the directories, the what files are there, and all that stuff, to the technologies used. Like, is the server a Linux server running Apache, like a generic LAMP stack, so Linux, Apache, MySQL, PHP, or is it like an Windows server, so it's running IIS, is it called?
That's correct.
Yeah, IIS is the Microsoft's web server, or the Windows web server. Although you could run not PHP, MyAdmin, XAMPP, XAMPP, which is the LAMP stack on Windows. But anyways, so yeah, if you know what technologies are being used, you could find out what find out how, find out what vulnerabilities the system has, or you can try out different vulnerabilities it might have and see if the server will be compromised because of those. And second is to also think as the developer who got the server up and running. So stuff like naming convention of files and scripts, like did you find a add user script and also a delete user? Then maybe for transactions there's an add transaction, and there might also be a delete transaction, or stuff like that. If the developer had insert user, it might have insert transaction. Stuff like that. There's typically reliable naming convention that's used because developers are people too, and they need to find their way around all the junk and files and all that stuff. So finally, mapping a web app and finding an angle of attack. So mapping a web application is an extension of forming an idea of the backend. It's specifically going through the entire website and trying to discover the files and the different stuff on the backend. So there's good old manual searching, like clicking through the web page. If there's a sitemap, like some turn of the century sites have like sitemaps, shows you all the pages on the site. Yeah, that gives you an idea. There's recursive wget. So wget downloads a web resource, and if you have it recursively, then it goes through the HTML source code and looks for different links, and it goes to those links and grabs that resource, and also looks in that resource itself for more links. Recursively, just like if you use recursive for RM, removes folders. So some techniques, there's some sites have robot.txt, which is to tell I guess, well, not quite hat, to tell good web crawlers or web spiders like Google's or Baidu or various search engines. They cache websites, and then this tells them what content not to cache. It might be stuff like dynamic content, such as users, or like for a blog, it might be a list of recent recent posts or something like that. Stuff that is constantly changing because the cached data might not reliably reflect the actual site. But what could also be in there is secure content, or I mean, data that the developer wants to have secured, that's sensitive. So a technique is to look for the robot.txt and look for what content's in there. Another is common file and directories. So that could be stuff like the directory php myadmin, which is just as it sounds. It's a admin control panel. So there's these universal, sort of like default universal names, directories, stuff like that. And if you just try out the that directory on the URL, so for example like example.com/phpmyadmin, then it might give you an error code saying 403 unauthorized. That resource exists. If it actually goes to phpmyadmin and shows you a login screen, that's pretty bad for the server. But it gives you an idea of what technologies are being used, what you could exploit, stuff like that. Finally, there's also spiders. So this comes with stuff like, say, Burp Suite. So what it is it automatically, sort of like recursive wget, it goes through different web resources and looks for links within them to go to other resources, and recursively goes through the site. They're a lot more advanced though, so they could do stuff like fill in forms, use drop-down menus.
Oh man, filling out forms, those are the best. I need to learn how to do that.
They even have dictionaries, so they could tell like what common files and directories to look for. Some of them even use robots.txt to specifically look for those files because there might be sensitive content in those. So spiders. Although there are some problems with automatic spiders in that if it accidentally accesses some area that not manages, that edits the site, then it might deface the site while it's running through it, or especially with like authenticated parts, it might be able to sign in if you give it like the username and password or something like that. But then it eventually, since it's going through every single link, it'll also hit the log out. So there's some problems with spiders because they're not smart, or not very smart. So they might do some, to humans, stupid things. So there's I didn't add it, but there's another method which is a combination between spiders and manual searching, where I think it is you manually search through the site, but the spider assists you or helps grab the resources while you're going through the site. So you could use your human intelligence and not click on the wrong things and fill out forms correctly, etc., etc., and the spider is able to get the resources. Yes.
So what would be an example of that kind of spider?
What would be an example of what spider?
A hybrid of manual searching and automation.
Well, I know Burp Suite has it. It might be in the pro version though. I honestly didn't hear about it too much. I just read about it in a book. So it might be Loch Ness Monster for all I know.
Alright, thanks.
It's in the Web App Hacker's Handbook though, if anyone wants to find out more. Anyways, okay, end. Any questions? Okay. Oh, we have a question.
So, what would be some example tools you would use to, for example, map out the website or something, like specific names, or like if I want to go further into this and actually use some of the tools, what would be some of the tools you'd recommend?
Well, there's Burp for sure. Burp has a spider. There's a free version of Burp, so you don't have to download a pirated version, although I'm pretty sure they exist. But yeah, the spiders included in the free version. There's always manually searching through. There's you could press Control U for the website source code, and there's also
Oh, I did that.
there's JavaScript. JavaScript files are just like HTML. It's widely or wide open to the public to see, just like your HTML source code. So you could look through those. There might be different links hidden in the website source itself, pointing to or indicating that there's some directories, or maybe developers left some comments and stuff like that. As I said earlier, there's like some common directories, like PHP MyAdmin. I mean, that's the one that comes to mind, but there's definitely tons of others. So you can manually look through those, or even write your own script to create your own spider. A simple one is recursive wget, although that mainly just grabs static content. I think that answered your question. Is there anything else?
So earlier you said something about figuring out like what backend is using, like IS or PHP, for example.
Yes.
How would I know if something is being ran in IS or PHP? Besides just like brute forcing, like PHP MyAdmin if it's there or something like that.
So you mean like figuring out the services and the server itself?
Mm-hmm.
Well, there's always good old nmap. So let's see. Okay, yeah, that shows up. So there you can use nmap. See the manual for it. A network exploitation tool and network and security port scanner. So this not only can scan ports, but what you can do with it is not going to use PN actually. That just expands the range of ports you're scanning, I think. There's O for detecting the server operating system, and there's SVs for services, but I'm just going to use A. So sudo, because the operating system and map detection requires super user access. Let's say example.com.
Is that an actual site?
Yes, it actually is. I was surprised when I first went to it. This might take a while. Shouldn't take too long. Should have used -v. It's verbose. It'll also tell you the progress. Let's see. Oops. Wrong button. Pause, break, where is it? Okay, never mind, it doesn't look like it's going through. Well, if you do enough recon on me, you'll find out what my server is.
So that's what verbose does, it shows everything that's happening?
Yes. So some notable stuff we already found. By using the manual a lot and being bored and mapping a lot. Because nmap is like a script kiddie tool in that you don't really need any skills to use it. So yeah, it's pretty easy to learn if you look through the manual. The manual's not too complicated. So we see discovered a port 111, 22, and 80. So the -a is probably going to take a while since it's doing absolutely everything. Oh, it's done. So I'm gonna full screen this. So since it's verbose, it's printing out a lot of content, but I think the notable stuff is here and also here. So let's see. Port 22, TCP, open, SSH. So 22 is the default for SSH. Open SSH. So it's running SSH. Let's see, 80, HTTP, Apache. So you can tell that this this server whoever the hell is using this server is running Apache 2.4.10, specifically for Debian. Let's see, 111 is RPC. I think that's remote controlling for remotely operating a computer. Well, I mean, like, not SSH, but like sort of like RDP, I think. I don't know, just off the top of my head. Anyways, so let's see, the OS. It could, Nmap can also try to find out what the OS is. So it's most likely it's Linux. It seems like pretty much everything here is indicating Linux. So sometimes they'll actually be able to successfully determine what a server is running. But of course, if you see the web server is like IIS, then that means it's some sort of a Windows server. But here, you can see it's some form of Linux, and from here, it might be a Debian server. So that's some ways you could tell, some of the services that are running. Of course, if you see like a PHP script, or if the website is example.com/contact.php or something like that, then PHP is also on the server.
Alright, thank you.
Awesome. Alright, yes.
So have you written scripts to like do those automated?
No. I did try actually. So I wrote an Nmap tool, which of course this wasn't done. I just basically had to do that humongous, like, do a whole bunch of Nmap flags. What it was supposed to do was you give it some sort of file with different IPs, and it scans those IPs and checks for what ports are available. Let's see. So what I also tried is to Nmap. Is this it? I don't think so. I think that's it. Or, you know what, we're going to get color coded here. Oops. So what I believe I tried to do was, I tried to get an IP address range, and it would use nmap-sp. I'm pretty sure that's what it is, which would tell if the host was up or down. And since you give it a range, this was an attempt at subnetting, I think that was right. Since you give it a range, then it would give you what hosts are up on a given IP address range, or and you'd be able to tell what basically what IP addresses are occupied by a machine. And what I would do after that would be to give it into the Nmap tool, and it would tell what services, what ports are open, etc., on those machines. But I never really got more than that, because I just looked through the manual or man pages for Nmap and stuff like that, and I wasn't actually that pro. Okay. Any other questions? Yes.
So are you going to be teaching more in depth on this later, or
I hope
what's
to.
the plan here?
Plan is to next week teach an intermediate course, going into the technical details, such as using burp using burp, looking at cookies and headers, using burp to actually go spider a website, use a proxy to strip out the earlier mentioned cookies and headers, or manipulate them. That's what comes to mind. Just basically going into the technical details. This is actually this talk is actually because I am personally also studying web apps, and I'm reading the Web App Hackers Handbook. So yeah, if you look through the book, I'm sort of saying, I guess, digesting the material. So read along and follow along. Okay.